There is a machine dying in the darkness. It does not breathe. It does not think. It does not know it is alone. And yet, it is the most distant thing humanity has ever touched. Right now, Voyager 1 is more than 16 billion miles from Earth, so far away that its radio signal, traveling at the speed of light, takes nearly 24 hours to reach home. That signal carries less power than a refrigerator light bulb, just 22 watts. A whisper, caught by massive antennas on Earth, listening carefully across the void. In late 2026, Voyager 1 will cross a historic threshold, one full light day away from its creators. No human, no probe, no message has ever gone farther. This is the story of how a small machine, built for 5 years of exploration, became humanity's longest-running conversation with the cosmos. The Voyager mission was only possible because of a cosmic coincidence. Once every 176 years, the outer planets, Jupiter, Saturn, Uranus, and Neptune, line up in a way that allows a spacecraft to visit them all using gravity alone. This alignment is called the Grand Tour. Instead of carrying enormous amounts of fuel, a spacecraft could steal momentum from one planet and fling itself onward to the next. Miss this window, and humanity would have to wait generations. In the early 1970s, engineers at NASA realized this might be their only chance. 2 spacecraft were approved. Not 1, but 2. Redundancy was survival. Voyager 1 was never meant to live this long. Its mission was designed for 5 years. The electronics were primitive by modern standards, less computing power than a calculator. But it was built with something modern machines often lack: margin, thick shielding, redundant systems, extreme testing. At its heart were radioisotope thermoelectric generators, RTGs, nuclear batteries powered by decaying plutonium-238. No moving parts, no sunlight required. Just heat, slowly fading over decades. Bolted to its side was something extraordinary. A message. The golden record is a time capsule of Earth. Not a broadcast, not a call for help. A greeting. It contains sounds of wind, thunder, whales, music from Bach to traditional folk songs, greetings in 55 human languages, images of DNA, anatomy, and daily life. Instructions, etched physically, explain how to play it. This record may outlast Earth itself. Long after cities crumble, after oceans boil, after the sun swells, Voyager will still drift, carrying proof that someone once lived here. In 1979, Voyager 1 reached Jupiter. What it saw changed planetary science forever. The Great Red Spot, larger than Earth, was revealed in staggering detail. But the real shock came from a small moon. Voyager discovered active volcanoes erupting across its surface. This was the first time volcanism had ever been observed beyond Earth. It proved something radical. The solar system was still alive, not frozen, not finished, dynamic, violent, changing. Next came Saturn. Voyager passed so close that its trajectory would determine its fate forever. The rings were revealed as thousands of thin bands sculpted by gravity. Then there was Titan. Titan. Wrapped in a thick orange haze, Titan hid something astonishing: a dense atmosphere rich in organic chemistry, possibly similar to early Earth. But here, a decision had to be made. Voyager 1 could either continue the Grand Tour or be aimed upward, out of the planetary plane, out of the solar system. The choice was made. Voyager 1 turned away from the planets, forever. In 1990, at the request of Carl Sagan, Voyager turned its camera back toward home. From over 6 billion kilometers away, Earth appeared as less than a pixel, a faint speck suspended in a ray of sunlight. The pale blue dot. Every war, every love story, every child, every civilization, all of it on that dot. Voyager's cameras were then turned off. They would never be used again. No more pictures, only listening, only whispering. For decades, Voyager traveled outward through the heliosphere. the bubble carved by the sun's wind. Then, in 2012, it crossed the boundary, the heliopause. Beyond this line, the solar wind yields to interstellar space. Voyager had left the sun's domain. Humanity had, for the first time, placed an object between the stars. Voyager's signal is unimaginably weak. It is received by giant 70-meter antennas of the Deep Space Network. Engineers do not talk to Voyager. They wait. A command sent today arrives tomorrow. A reply comes the day after. Conversation measured in days, patience measured in years. In late 2023, Voyager began sending nonsense, zeros and ones with no meaning. A cosmic dial tone. The problem traced back to corrupted memory, hardware older than many nations. Engineers performed surgery across billions of miles. They rewrote instructions, rerouted systems, and slowly, Voyager spoke again. It was still alive. Every year, Voyager loses power. About 4 watts. Instruments are shut down one by one. Heaters go cold. Eventually, there will not be enough energy to speak. Sometime in the early 2000s and 30s, Voyager 1 will fall silent. No goodbye, just nothing. Sometime in late 2026, a line will be crossed that no human object has ever crossed before. Voyager 1 will become one full light day away from Earth. That distance, about 25.9 billion kilometers, means this simple truth. A radio signal sent from Earth will take 24 hours to reach Voyager, and Voyager's reply, another 24 hours to return. A single question, 2 days of waiting. This is not a boundary you can see. There is no marker in space, no flash, no alarm. Only time. At that moment, Voyager will exist in a new relationship with humanity, no longer just far away, but separated by an entire day of light itself. And yet, it will still be moving forward, still obeying the same physics, still carrying our whispers, our music, our intentions, even as its power fades, even as its voice grows weaker. One light day out, a machine built on Earth, now truly belonging to the stars. Voyager 1 is not failing. It is being carefully, intentionally shut down. At NASA, engineers face a quiet, unavoidable reality. The spacecraft's nuclear power source is weakening year by year. Its RTGs lose about 4 watts of power annually, a slow, predictable decline. To keep Voyager alive, teams make difficult choices. One by one, instruments are turned off, heaters are shut down. Systems that once gathered priceless data are sacrificed, not because they are broken, but so the spacecraft can continue speaking at all. Each shutdown is planned months in advance. Commands are sent across billions of miles, knowing the response will come days later. In recent years, even backup systems, silent for decades, have been briefly reawakened, their dormant components warming for the first time since the 1980s. It is not maintenance, it is triage. Every decision buys a little more time, a few more bits of data, a few more whispers from the dark. Sometime in the early 2030s, there will be nothing left to turn off. And when the last transmitter falls silent, Voyager 1 will still be moving, long after its makers have stopped listening. Voyager will not stop. For tens of thousands of years, it will drift through the galaxy. It may pass near other stars, it may be found, or it may wander forever. A relic of a brief, bright species that looked up and asked, "What's out there?" If this journey moved you, subscribe for more deep space documentaries. And tell us in the comments, if Voyager is discovered one day, what message do you hope it delivers about humanity?